The overall goal of this procedure is to generate phospholipid bilayer vesicles with increased control over membrane unilamellarity, monodispersity, and internal contents. Using CAD, a chamber is manufactured from acrylic sheets and natural rubber. A suspended lipid bilayer is produced by loading the chamber with lipids and solution. Next, an inkjet containing the solution to be encapsulated is set up with the jetting apparatus. Once the appropriate settings have been established, jetted fluid pulses will produce lipid bilayer vesicles. Ultimately, microfluidic jetting yields repeatable, monodispersed bilayer vesicles.
The main advantage of this technique over existing methods like electroformation, emulsion, or droplet generation is an increased level of control governing membrane unilamellarity, monodispersity, and internal contents.
Demonstrating the procedure will be Johanna Heureaux, a graduate student from my laboratory, and assisting will be Karan Patel, an undergraduate student.
Using CAD software, draw a shape for the chamber that can be made from acrylic using a laser cutter. First, drill 1/16 inch through holes on both sides of the assembled acrylic chamber that will drain to the infinity-shaped well. Second, cut a small rectangle with scissors from a 0.2 mm acrylic sheet to serve as the bottom of the infinity-shaped well. Secure this in place with quick-drying adhesive, making sure not to get glue in the viewing areas. The acrylic sheet should be